Hello everyone, welcome to another episode from Chem Edexcel. Today we are going to talk about Unit 1 IAS thing. So today I am going to talk about relative atomic mass, or we say RFM. Now, once we identify what are ions, atoms and molecules, the next part is how to measure the mass of an atom. So mass of a single atom is too small, we can't measure it using the regular scale. So scientists thought that we should have another different scale to measure the mass of an atom. To do so, they introduced atomic mass unit. Atomic mass unit is the 1/12 of the mass of C12 isotope, right? So we say it as the atomic mass unit, AMU. So atomic mass unit is defined as like this, so we can write it. Atomic mass unit, AMU, we say it's atomic mass unit is the 1/12 of the mass of carbon 12 isotope. Right, so that's the atomic mass unit. Then what is RAM value? Then RAM value is called as relative atomic mass. That is, we defined as the weighted average mass of an atom. Weighted average mass of an atom with respect to 1/12 of the mass of carbon 12 isotope. That's what we define as the relative atomic mass. Weighted average mass of an atom with respect to 1/12 of the mass of carbon 12 isotope. So once we have the RAM value for elements, the importance of this carbon 12 isotope is when we measure the mass of an atom with respect to this scale, it is easily equal to the mass number. For example, sodium. Sodium is 1123. So RAM value of sodium is 23. Iron 2658. RAM value of iron is 58. So always the RAM value is equal to the mass number. So we use RAM value to measure the mass of an atom, right? So it's a very easy. So we know that if you know the mass number, that is its relative atomic mass. It's the mass of that particular atom with respect to the atomic mass unit. Right. Now, for some elements we have isotopes. We commonly call them as isotopes. So to measure the mass of an isotope, right, we can't just use the value we just used. For them we have to use a calculation. So we'll see how we can use the calculation to measure the mass of an isotope. Common one is chlorine. Chlorine we have 1735 with 75% abundance, and chlorine 1737 with 25% abundance. How do we measure these values and how the masses of isotopes are measured is discussed in chapter 2, where atomic structure. So RAM value of chlorine is not exactly 35 or 37. You can't say which one we use, because in chemical calculations we have to have a proper value. So what we do is like this. We have 35 into 75% plus 37 into 25%. So the RAM value of this one comes as 35.5. So that is the RAM value of chlorine. That 35.5 is the one we use in the periodic table. So when you take a periodic table, you can see the mass number of chlorine is not 35 or 37, it says 35.5. We'll do another one, common one that has another example. Let's say magnesium. We have 24, mass number 24, that is with 80%. We have something magnesium 25, that is with 9%. Then we have magnesium 26, which is 11%. Then how we can use the RAM value of magnesium then? Then it is 24 into 80 plus 25 into 9 plus 26 into 11. So divide everything by 100, you get it as 24.31. So that is how we do the RAM values. It's a very common one in the past papers as well. So if I just show you a past paper question, right? Okay, so something like this. See, it's a past paper question. A sample of an element X contains only the isotopes shown. You have 58, 60, 61, 62, 64 and the percentage abundance are given, and you are asked to find it to 3 decimal places. So the same way I did earlier, you can do it. 58 into 68.077, 60 into 26.223, 61 into 1.14. So when you do the calculation, you can get the answer. I think answer is A, right? You can easily omit answer B and C, neglect them, because they ask answer to 3 significant figures, 3 decimal places. So answer is A. So that is how we do the RAM calculations. It's very easy one. Now if they want to give a harder question type, they can ask like this. This is also something they have asked in past papers, right? Something like this they have asked. We'll see what it is. Like this. Potassium has 2 isotopes, 39 and potassium 41. They have given the RAM value of potassium is 39.1. The question is, what are the percentage abundance of each isotope? This is actually a past paper question, and this have asked in many different ways as well. So potassium has 2 isotopes, 39 and 41. The RAM value of potassium is 39.1. Then they have asked, what are the percentage abundance of each isotope? Then how do we do this one? This is something like this. A thinking part is there. So we can take, this is how we do these questions. We can take potassium 39 as X percentage. Then it is only 41 will be 100 minus X percentage. Then the same thing. So RAM value is 39.1, that is equal to 39 into X plus 41 into 100 minus X. Everything divided by 100, that is equal to 39.1. You can use a cal to do this one. If I just do 3910 equals 39x plus 4100 minus 41x. You can solve this x and you can get it as 95. So that's the past paper question. So potassium 39 is 95%. Potassium 41 is then just 5%. So you can do a questions like this. These are past paper questions they have asked. So that is the idea of relative atomic mass. Now using the relative atomic mass, we go to the next part, that is the relative formula mass, and we'll see what relative formula mass is. Right, the relative formula mass, the next one. Now once you calculate the relative atomic mass, we can find the relative formula mass. Formula is a compound or a molecule. So let's say sodium sulfate. Sorry. So the RAM value of sodium is 23, sulfur is 32.1, oxygen is 16. These values are given, or you can take it from the periodic table. So what is the relative formula mass? We sometimes call it as RFM. So 23 into 2 plus 32.1 into 1 plus 16 into 4. So when you just add these stuff, you can get the answer. So it's 46 plus 32.1 plus 64. get the answer as 142.1. So this is a relative formula mass. Another one, MgNO3 twice. So magnesium is 24.3, nitrogen is 14, oxygen is 16. So what is the relative formula mass of this one then? 24.3 into 1 plus, now this 2 belongs to both nitrogen and oxygen, so that is 14 into 2 plus 16 into 6 then, because 2 into 3 is 6. So this gives you 24.3 plus 28 plus 16 into 6. You get 148.3. That's the relative formula mass. Sometimes you can get a bigger ones like these stuff. I'll show you. So we'll do a past paper one. Okay, before that, like copper sulfate 5H2O, which is copper equals 63.5, sulfur is 32.1, oxygen is 16, hydrogen is 1. So how to do this one then? Relative formula mass. It's a very common question in past papers. 63.5 into 1 plus 32.1 into 1 plus 16 into 4 plus, now this 5, this belongs only to H2O, so 5 into water is 18 total mass. You can get the answer from there. Get the answer as 249.6. So this is the RAM value of this one, copper sulfate 5H2O. So 5 belongs only to H2O. So we go to past paper questions. So very common past papers are there. Okay, sodium carbonate NH2O. What is the relative formula mass of hydrated sodium carbonate 10H2O? So the same thing, you can put sodium, carbon, oxygen, and 10 only belongs to water. So you can then answer as 286. 286 is the answer in this case. Let's say this is another one. These are for the next parts. So this is a very common questions that you can do, right? So if you go down, I think there's another one, this same question. See, what is the relative formula mass of hydrated barium hydroxide 8H2O? It's a very simple one. So I put barium 2OH and 8H2O, right? So you can get the answer here as well, the same manner. So if I do it, so barium is 137.3 plus 2OH means 17 into 2 plus 8 into 18, water is 18. So you get the answer as 315.3, the answer is D. So that is the relative formula mass, right? So we know what is relative atomic mass, we know what is relative formula mass. So once you know the relative formula mass and the relative atomic mass, we can calculate the mass percentage of any substance, right? To calculate the mass percentage of any substance, we can use it. So using the relative atomic mass and the relative formula mass, we can calculate the mass percentage. For example, mass percentage of nitrogen in ammonium nitrate NH4NO3. So how do you do this? Atomic mass of nitrogen is, relative atomic mass is 14. 14 into 2. Why 2? Because you have 2 nitrogen, one here and one here. Should divide by the total mass. So nitrogen is 14 into 2 plus you have 1 hydrogen, 1 into 4 hydrogen, so 1 into 4 plus 3 oxygen, 16 into 3. That run into 100% total. So 28 plus 4 plus, so total value is 80. So 28 divided by 80 into 100, you get 35%. Right? There are many questions like that as well for the past papers. So mass percentage of water in Na2CO3, 10H2O. What is 18? You have 10. We learn how to find the relative formula mass of the entire thing, which comes as sodium is 23 to 2. The total value comes at the bottom will be 286. 286 is the total value of this, right? 286. That one into 100. So 180 divided by 286 into 100, you get 62.9%. That's how we do the mass percentage of atoms or compound or molecule we can do. Right. So today what we learned is what is atomic mass unit, relative atomic mass, how do we find the relative atomic mass using the mass percentages, and we found the relative formula mass. Okay, so the next class we will be discussing how to do a chemical calculation using the concept of moles. So I am putting these videos as a small videos that we do in a class. So stay tuned for the next one. So this is how we do the calculation of relative atomic mass, relative formula mass, and how to find the mass percentages. Thanks for watching.